Swayam Prabha. Digital India. Educated India.
So welcome back. This is a new topic where we are going to talk about the volcanoes and related hazard. Now, if you refer the couple of slides from the previous lectures from plate tectonics and all that, we very briefly talked about the distribution of volcanoes along the plate boundary, and this is very typical that wherever there is an one plate subducting below another one, you will find the volcanic features. But if you are not having any plate subducting with respect to one another, then you won't be able to see such feature. So for example, if you are having a plate subducting below, that is your either you talk this is mostly the oceanic plate, and the overriding plate could be an oceanic plate or the continental plate. Then as soon as this material or the plate portion reaches the asthenosphere, it will start melting, and then this will result into the formation of volcanoes on the surface. So if we look at the overall configuration of, I hope you note it down, but you can just put again this one. Okay, so this is one plate moving below the another one, so the melting will result into the formation of volcanoes on the surface. Now if this plate is no more subducting, that is in the case of you are having this an oceanic plate here, and this is also an oceanic plate. But if you are having in configuration of like oceanic plate subducting below the continental one, so this continental plate, and this one is your oceanic plate, then you will have the volcanic eruptions on the continental plate side. But as soon as if either you are having a continental plate which is adjacent to this one, and if it reaches, because this is moving and this is riding over, so when this two meet, that is in continental and then continental, a similar situation what we have with, so this is the broken oceanic plate here, and this is the continental plate. So both will try to sort of collide with each other and result into the mountains. Okay. So this is very much similar to what we have discussed in the scenario between the Indian plate and your Eurasian plate, where both of this are your continental plates, and the result what we see is your Himalaya. So this thing you should keep in mind when you are talking about the location or the distribution of volcanoes. So if you look at the distribution with respect to the plate tectonics or the plate tectonic boundaries, then you will find that most of the, not most, but all the volcanic eruptions which are active or dormant, they are along the plate boundaries. And wherever there is no oceanic plate subducting below, like in the case of the Himalayas here, we have both are your continental plates, but here we have still the oceanic plate subducting below the oceanic and partly plate. Here both are oceanic. Here also we have the oceanic plate subducting below the continental plate. So we see the volcanic eruptions on the continental side. And very good example, if you look at, is from this region. This is what we call the Pacific Ring of Fire. So this portion is been termed as Pacific Ring of Fire, where we see a very beautiful distribution of volcanoes. We have one in India, and this one is here. This is known as Barren Island. And then we have series of active volcanoes which are sitting along the Sumatra arc. So volcanoes, mainly what we describe is typically a cone-shaped hill or mountain formed at a vent from which molten rocks, that is the magma, or the magmatic gases, reaches the Earth's surface and erupt. So this is a basic example, and the backdrop of the photograph. You can see the cone-shaped hill or the mountain, and from the center, that is your vent through which either the gases or the molten rocks, that is what we call magma, has been poured out. So once the magma reaches the surface, it is termed as lava. Then the flow starts. So the flow which you see here, in some locations, are the lava flow. Now I'll start with one example from US, that is St. Mount Helens. This was a well studied or well observed volcanic eruption which took place or which the volcanic eruption took place in 1980 also, and later also. But the most important part was that they monitored this volcanic cone and how it progressed and until it erupted finally. So this is a digital elevation model which has been created using the topography of that region and how well it was been studied, and that I'll just show in a couple of slides. Okay. So the previous slide which I was showing was looking this side of the dome, and this is the Mount St. Helens. The height is almost like 2,574 meter. So it's quite high, the summit, and the observations were been made by a geologist who got killed during the eruption. His name was Dr. Johnston, and this observatory now has been named after him. It's known as Johnston Ridge Observatory. So he was sitting on the top hill over here and then watching and photographing all the movement of the structure, and he got killed. The reason was, I'll come to that in the next slides. So this is a picture from the same observatory which shows the depression here, what we call crater, and this was when formed when the portion or the top portion of the cone was totally blown up. Now what they have done is that they have preserved the complete the incident, okay, that happened at that time, and you can see even in some locations the logs which got buried or were blown up because of this eruption. And if you carefully see, there's this almost 2,700 meters high hill is capped by ice, okay, or the snow. It's a snow cover mountain, so it's remained quiet for about a century. It remained quiet actually for about a century. इसको कट करेंगे, इसको वापस ले लेंगे, ठीक है. So if you look at the top of this mountain, what you see is they are covered with this is covered with snow, and this plays a very important role in terms of like creating a lava flow, because when the lava flows or comes out from the vent and drops on the snow covered peak, and that will result into the mud flow or the lava flow. So this volcano, it remained quiet for about a century. Nothing was happening. As magma moved, it resulted into bulging of mountain. So in the center here there was a dome, okay, or a bulge which was been formed, okay. So, and it erupted in 1980 on May 18th with a small magnitude of earthquake 5.2. Hot rocks plus ash flowed down with a temperature of almost 600 degrees centigrade, and the speed was almost 1000 kilometers per hour, so more than what the airplane flies. And this the material which was been poured onto the surface through the vent, that is the rocks plus ash, very high temperature, it melted the snow cover here, and that resulted into a lava flow or like a mud flows. More than 600 square kilometer of forest was completely leveled, and the trees were swept away because of the speed as well as the high temperature. The trees, the forest area was completely leveled. So this is what it is been preserved. Now this is in part of a national park which shows the lined up or the oriented tree trunks. So tree trunks which shows this is the direction in which the lava flowed. So a lot of tourists they come and visit this area, and still they can even watch and see the dome where or the crater where the domal effect has been seen, as again the magma is rising in that crater. So they have an observatory where they constantly keep on monitoring the earthquakes, the micro earthquakes. So if suppose they get an indication that the multiple earthquake, micro earthquakes are occurring, then they can indicate or suggest that there is a movement of magma into the vent. So at present, when I visited this area, this is the dome which you can see, which is coming up in the crater. So this is a crater here you have, and within this the center part is bulging up. So the time will come, this will again erupt. So what they are doing, they are constantly watching it, so they know that how it is growing. So if there is a sudden growth which has been seen here of this portion, then they can issue the warning that there will be an eruption very soon. This is a close-up of that, and this was like from 2004 to 2006 renewed activity was observed, where this part was again uplifted because of the magma getting into this. So volcanoes again can be also defined, can be defined as a gap in the earth crust through which the molten rocks or the magma comes onto the surface. It is a conical mountain formed around the vent through which molten mass comes out to the surface. So, as we were talking about that the volcanoes and related hazard, there are few historical events which are been listed, and this data has been taken from the MIT Press, Cambridge, which talks about the worldwide volcanic eruptions which were deadly or devastating. So, the list on the in this table on the left hand side shows the volcanoes and the cities which they affected, the year in which they were erupted, and what was the effect in brief. So, one is, which one is was deadliest one was, I am not going to talk all, but yes, of course few we will just discuss and try to understand that what was the effect, the quantum of effect because of the volcanic eruptions. This is in Italy, Vesuvius. It occurred in AD 79, destroyed Pompeii city and area and killed almost 16,000 people. And it says that city was buried by volcanic activities and then rediscovered in 1595. So, until then they were not even aware that there was such a deadly volcanic eruption which killed almost 16,000 people, and the city was completely buried under the volcanic ash and the debris. Then another one was which also affected the climate, okay, and this was from Indonesia, Tambora. Eruption was in 1815, killed almost 10,000 people, and 18,000 people were been affected, producing a global cooling where a complete year was without summer. So, you can understand that even if you are sitting away from the location of the volcanic eruption, if the volcanic eruption is very severe, then it can result into the global climate change, okay, or the global climatic effect also. But if the volcanic eruption is very frequent in most of the areas, then of course it will in total affect the climate. Then there is Krakatau, Indonesia, 1883, tremendous explosion, more than 36,000 people were killed, and that was because of the tsunami. Because since we have this volcanoes, few of the volcanoes which are located close to the ocean, if you are having a configuration of oceanic subduction, so if you have oceanic plate subducting below, so you have an ocean here, so if there is an eruption here, it will affect the nearby area and result into the landslide, massive landslide, which can result into the disturbance of your water column, as it was experienced during the recent earthquake and volcanic eruption, same from Krakatau. Then Mount Pelly, eruption of 1902, says the ash flow killed 30,000 people in a matter of minutes. So you can understand the impact, that how fast the flow was, okay. The ash flow was with a tremendous velocity, which killed almost like 30,000 people. Then we take the Villarrica from Chile, The eruption was in 1963-64. It forced almost 30,000 people to evacuate their homes. Then we have Mount St. Helens in Washington DC, 1980. Debris avalanche, which I was showing in the previous photographs, the Johnston Ridge and all that, and lateral blast and mud flows. This mud flow is your what we were talking about. If you have the magma plus snow, it will result into lahar flows. So this happened. Now, very interesting, the eruption was very deadly. Only 57 people were been killed. The reason was this area is sparsely habited, and the scientist or the geologist who was killed in this eruption, he was able to at least send his last voice on radio saying that it is coming, but he never thought that the volcanic eruption taking place here and he is sitting somewhere far away in the ridge, the flow will come right up to this ridge. Okay, but the flow was so fast that it swept this whole area, and when the tourists visit this area, they can listen to or hear the voice or they watch the movie of this eruption. Then there is again an Filipino earthquake, Mount Pinatubo, 1991. Tremendous explosion, ash flow, mud flow combined with a typhoon. So this was an additional added effect of typhoon, killed more than 740 people. Several thousand people were being evacuated. Then again another one is in Chile, 2008. Almost 5,000 people were evacuated. Now what we see from this events here, that slowly we are getting into the process of evacuation. So in the starting, if you see the 79 AD event, people were killed, people were not able to understand the phenomena, but later if you see most of the earthquakes, what we are able to learn is that people were been warned and people were been asked to evacuate the locations. So this is what we learn from this topic, that yes, we have slowly, as there is a development in science and advancement in science, we are learning more and more about the volcanic eruptions and the processes, and we are trying to reduce the effect to the people and the property. Then this one is from Iceland, 2010. Now this was the event which put large amount of ash in atmosphere, which disrupted the air travel in United Kingdom as well as in Northern Europe for several weeks, because no flight was been allowed to take off or land in this region. So this was one of the devastating one. Of course, not many people got affected because of this. So eruption of Mount Vesuvius, Italy, in AD 79. So Mount Vesuvius eruption, a kind of pyroclastic flow. So it includes the rock fragments as well as the ash, destroyed the Rome town, Pompeii and Herculaneum, killing almost or more than 16,000 people. Archaeologists excavated the remains of some 2,000 people suffocated in this eruption or because of this eruption. So what they found was the victims' plasters, plaster cast, even the adults, children's, dogs, and in the dead position. Another important point which one can note down here, that they even did not get time to move out from this place. The flow was so fast. So Pompeii was buried by up to 3 meters of ash. So 3 meters of ash is more than enough to cover the complete city and remain to keep it hidden from the people, which was later excavated, and they came to know in 1500 AD or so. So I'll stop here and we'll continue in the next lecture. Thank you.